Okay, so in the last video, we looked at a growth problem. Now we're going to look at a decay problem. But first, let's get an additional definition, half-life. The half-life is the time it takes for a substance to decay to half of its original size. Now, different substances will have different half-lives. If something is really stable, like metal, for example, it might have a half-life that is hundreds of thousands of years or even millions of years. However, something that's highly radioactive might have a half-life of just a few minutes. So it really depends upon how stable something is. Now, when we see half-life always refers to an exponential decay problem because something is decaying when we're dealing with a half-life. Now, we'll see as we get ready to do this problem that this is done exactly like the growth problem, though, that we saw before. So let's take a look. A scientist begins with 250 grams of a radioactive substance. After 250 minutes, the sample has decayed to 32 grams. Rounding to 5 significant digits, write an exponential equation representing this situation, and then to the nearest minute, what is the half-life of the substance? All right, so let's just start with our formula from above, y equals a sub 0 e to the kt. Now let's realize that this is a decay problem. So the first thing we're going to end up doing is solving for k, just like we did with the growth problem we saw before. But k will end up being negative since this is a decay problem. First thing we're going to do is put the initial amount of the substance in for a sub 0. That's 250 grams. So there's our first step. Now we have a point. We have the point. After 250 minutes, there are 32 grams. So let's fill in. 250 is T, 32 is Y. So 32 on the left, e to the K times 250 in the exponent. All right, now, this is an exponential equation. Let's solve it. Our steps to solving an exponential equation. First, we need to get our exponent and its base by itself on one side. We've got this 250 in front of it, so it's not by itself. So let's divide out that 250 first. On both sides, of course. On this side, 250 will be gone. 32 divided by 250. And that actually does not have a bunch of decimals. It's just as 0.128. And then over here, this will be e to the 250k. Again, I'll just put the 250 in front of the k because it looks better in front of the k instead of in back of it. All right, now that we've got the exponential portion by itself, let's put the natural log on both sides in front. On the left, we want to put the natural log of 0.128 into our calculator. And that gives us negative 2.0. Now, since we're supposed to take this out to 5 significant digits, I'm going to take it to 7 right now. Let's see, 4, 5, 6, 7. All right, now on the right side, natural log and e cancel each other out. We just get 250k. And then our last step, let's divide by 250 to get k by itself, and we will know what our k is. K is equal to, I'll go ahead and round it to 5 decimal places now, so negative 0.0082229. Now, let's take our k. We're going to go back to the original equation that I had started to set up right here. We're going to put k in. So we've got 250 e to the negative 0.0082229. And actually, since it said to round to 5 decimal places, I could have rounded that off right here. And T. Okay, so we're just plugging in for that K right there. All right, so now it's asking, what is the half-life of this substance? So half of 250 would mean that it decays to 125 grams. So we put 125 over here. And, oh, goodness. So now we're going to solve this thing to find out what T is. So again, we're solving an exponential equation. Let's get this exponent and its base by itself. We have to divide out the 250 first. When we do that, on the left, 125 divided by 250 is a half, or 0.5. Now, let's apply the natural log on both sides. On the left, let's put the natural log of 0.5 into the calculator. That is negative 0.693142. On the right, natural log and e will cancel, and I'll just get this. So let's continue solving it for t. Let's just divide out the number that's in front of our t, and we will have our answer to how long this thing takes to decay to half of its original size. On the left, we're just going to get t. On the right, let's put that into the calculator. And that is 84.29474. And let's see, was that days? That was minutes. Okay, so after about 84 minutes, it will decay to half of its original size. Now let's notice it took 250 minutes to decay to 32 grams. So certainly this should be less in time-wise to decay to 125 grams. It still has to decay down to that 32 grams after 250 minutes. So this is about right. After 84 minutes, it's at 125 grams.